Let's take a look at this practice test for Unit 1. We're solving equations, inequalities, and absolute value problems. So we're going to take a look at problem 1. First thing we notice is we've got some parentheses. So let's go ahead and simplify it by distributing. So we'll distribute through here. We get 3x plus 12 on this side. We have a 7x there. This is one of those that has a variable on both sides, and it just happens to work out that we do want to move the smallest one here. But more importantly, there's only one constant here, the 12. So we're going to go ahead and move that 3x. We're going to do that by subtracting 3x from both sides. So these are going to cancel off. Those are additive inverses. We've got a 12 right there. We get a 4x over here. And now we need to get rid of that multiplying by 4. So we're going to divide both sides by 4. So we get x on this side, and then we get a 3 over there. 4 goes in here once, and 4 goes in there 3 times. So we get 3 over 1. We'd go ahead and simplify that. Or we can just think of it as 12 divided by 4, and we're all set to go. Let's take a look at this next one on number 2. You'll notice that we've got this negative here, this minus sign. We're taking 5y and then we're subtracting all of this stuff in parentheses. So we're going to go ahead and distribute that negative through. So we've got a 5y here, we've got a negative 2y. Negative times negative makes a positive 10, and then we've got the 25 over here. We're going to go ahead and continue simplifying. So we've got 3y, and then we've got that plus 10 equals 25. Now we've got a two-step equation. There's the variable term, so we're going to isolate that by subtracting 10 from both sides. So we get 3y on this side, we get a 15 on the other side, and again, just like over there, last step is we're going to divide. So we're going to divide both sides by 3. Those are going to cancel each other off, so we get, let's see, 15 divided by 3 is 5. Go ahead and circle that, and that's our answer. Taking a look at this next one, we've got a whole bunch of simplifying to do here, so let's take a look. We're going to go ahead and combine these two like terms. That's going to be a negative 2m, and then we've got that plus 13. We've got a 5m minus, remember that would be a 1m, so this is going to be a 4m on this side, then a minus 3. Now we can take a look at getting the variable on one side. I am going to go ahead and move the smallest one here, so I'm going to do that by adding 2m to this side. Now, I'm just going to go ahead and cross it off there. So if I'm getting the m's on this side, that means I want to get the constants on the other side. So let's save ourselves a step. Let's move this 3 to the other side. We do that by adding 3. So we get 16 on this side. We get a 6m over here. And then we're going to divide by 6. That's going to cancel off. So we've got an m on this side. Now we do need to simplify this. 6 doesn't go in evenly, so we'll stop thinking of this as a division problem like we could up above on this problem right here. And let's think of it as a fraction. So we need a number that goes into 16 and 6 evenly. 2 would fit the bill there. That's the biggest one that goes in there. So 2 goes in here 3 times. And 2 goes in there 8 times. So the answer on this one is 8/3. So we'll go ahead, whoops. Get that out of there, so we'll go ahead and circle that and move on to the next one. Okay, on this one here, we've got some fractions in this, so we're going to go ahead and clear fractions. We do have to be a little bit careful because we've got this coefficient outside there. So we're going to multiply both sides by something that will cancel off a 7 and a 3. Well, the least common multiple of the two of those would be 21. So I'm going to multiply this side by 21, and I'm going to multiply this side by 21. So when we multiply here, we need to be a little careful. The 7 is going to cancel to be a 1, and this is going to cancel to be a 3. So what we've got here is we've got a 3 times 2 times this stuff in parentheses, the 3x plus 5. Please don't make a mistake and distribute it to the 2 and then distribute it through there. We're multiplying the two of these together. 3 times 2 is 6. And then that stuff in parentheses, we're going to take care of that in just a second. On the other side, we cancel a 3 here. 3 goes in there once. 3 goes in there 7 times. So we've got x plus 2 times 7. Now, if you wanted to, you could put the 7 in front. It doesn't really matter. The important part here is that we're going to distribute through to both of these. So we get an 18x. We get plus 30. Then we're going to have a 7x plus a 14. These sides are simplified, so now we can go ahead and solve. So I'm going to move the 7x to the other side. I'm going to do that by subtracting 7x. We're going to move the 30 to the other side. We'll do that by subtracting 30. So those go away there. So we get an 11x on this side, and then on this side, let's see, what do we get here? We get a negative 16. We're going to divide both sides by 11, cancel those off, so we get, make that look right, negative 16/11. So we'll go ahead and circle that, and that's the answer on that one. All right, on to number 5. So on number 5, we've got some more fractions to deal with here. This one's kind of interesting because of the 4 terms involved in this equation, One of them does not have a denominator. Remember, if there's a fraction in the problem, we might as well think of everything as a fraction. So I'm going to go ahead and put that over 1. And what we'd like to do is we'd like to get rid of all of these denominators here. No problem getting rid of a 1, but we need to get rid of a 4, a 10, and a 5. So we need to think of the smallest number that all of those will go into, the least common multiple, if you want to call it that. So let's see, 4 and 10 and 5. Well, a 10 would take care of 10 and 5, but wouldn't really take care of the 4. A 20 would take care of all of those because, let's see, 4 goes into 20, 10 goes into 20, and 5 goes into 20. 20 is actually the least common multiple there. So here's what we're going to do. We're going to multiply this side by 20, and we're going to multiply the other side by 20. Now, when we're distributing through, basically here's what's happening. We're making sure that every term on both sides gets multiplied by the 20. So I'm going to write this out completely. This is 20 times n over 4, and I'm going to put that 20 over 1. Then this is minus, we'll do the 20 times the 2, and if you wanted to, you could put those both over 1. Then on this side, we have 20 times, and I'm going to use the set of parentheses on this side, 7n over 10. Again, I'll put that over 1. And then we've got the plus, and we'll put a 20 in front here, and then we'll do the 2 over 5. So here's what's happening on each one of these. We're doing some cross-canceling. 4 goes in here once, 4 goes in here 5 times. There's nothing to cancel off right here. 10 goes in here once, 10 goes in here twice. 5 goes in here once, and 5 goes in here 4 times. So what do we have left here? We've got a 5 and an n, so that's a 5n. We've got a negative 2 and a 20, so that's going to be negative 40, so I'll have a negative 40 right here. Multiply these together, we've got a 2 and a 7h, so that's a 14h. And multiply the 4 times the 2, and we get a plus 8. And then we just solve it like we would any other equation. So I'm going to move this one right here. So I'm going to move the 5n, which means we're going to move that 8, that constant, over to the other side. So we're going to subtract 8. So this is going to give us negative 48 on this side, and then 14n minus 5n is going to be 9n, and then we're just going to divide both sides by 9. So we cancel them off here, and I get n equals. Now we do need to be a little bit careful here. Let's see, 48 and 9, can that reduce? If you get stuck on something like this and aren't sure, you can always throw that in your calculator and have it reduce. 3 goes into 9 and 3 goes into 48. 3 goes in here 16 times, so this is a negative 16 on the top and a 3 on the bottom. So the answer on this one is negative 16 over 3. Okay, let's take a look at the last two on this page. We've got some formulas to solve. We need to solve for the indicated variable. On this one, on number 6, we've got this ugly looking mess right here, and it says solve for m. Now, when we were doing this before, we did run into some problems where we had a squared variable and people were trying to get rid of it by taking a square root or something like that. Remember, we're treating everything but this variable right here, that m, as a constant. So we really don't care that that's been squared. What we want to do is we want to get that m all by itself. So basically, we're going to think of this right here as a fraction. So we could multiply both sides by r and clear those fractions and then divide both sides by v squared. But let's just go ahead and get rid of that fraction by multiplying by its reciprocal. So we'll multiply this side by r over v squared. We'll multiply this side by r over v squared. Those v squareds are going to cancel. The r's are going to cancel. So that leaves an m on this side. And then we have an f times a lowercase r over a v squared, and that would be it. Now, if you want to go ahead and change that around so we've got the variable that we solved for on the left-hand side, that's totally okay. So we'll have f times lowercase r and then v squared, and we'd circle that. Either one of those is just fine. And then this is an interesting one. You'll notice that the variable that we're solving for is in the denominator. So if it's in the denominator, we've got to get it up where we can work with it. Now, you can't just multiply both sides by an r because that r is attached to the t. So what we're going to do is we're going to put that in a set of parentheses, and we're going to multiply both sides by the denominator. Just like we were doing up here, we want to cancel off that denominator. Just like we multiplied this side by r to cancel off the denominator, we're going to multiply by t plus r on this side. So we've got a t plus an r here, and we're going to multiply this side by t plus an r, and I'll put both of those in parentheses. Now, it's important to note that when we cancel this off, we are canceling that entire number, whatever that expression happens to be, whatever it represents, we're canceling that off completely. So we get an s on this side, and then we're going to distribute through here. So this is going to be a p times lowercase t plus a p times a lowercase r. Now, what we've done here is we've gotten rid of the parentheses. We've got the the variable that we're trying to solve for, the r, up where we can work with it, and now this is the variable term. So I'm going to go ahead and put a dotted circle around this right here. We want to start by getting that by itself. So in order to do that, we're going to get rid of the pt. So we're going to subtract pt from this side and subtract pt from this side. And you'll remember when we were talking about this, the cool thing about problems like this is these are almost easier than regular solving, because there's really not a whole lot of simplifying that we can do here. This is an S and this is a PT. We don't know what those are. They're not like terms. So to finish this off, what we're going to do is we're going to divide both sides by P, just like that's the coefficient there. So we'll divide by P here. So we have R equals, this would be S minus capital P times T over capital P, and we'd go ahead and circle that. Now, if you wanted to get a little bit fancy and clean this up just a little bit, there's nothing wrong with leaving it like this. We could break this into two fractions. We could do this as S over capital P and then minus PT over P, and then we could cancel those P's off right there. So this would be R equals S over P minus a plain old T. Either one of those is fine. Probably like this one just a little bit better, just because it's kind of, I mean, we're going to have to deal with a fraction either way, so it doesn't really matter. But this would be just fine if you wanted to write it like that. Let's take a look at this next page, problem number 8. It says, write your solution in interval notation and as a graph. So we need to do both interval notation and we need to graph these. So remember, we solve inequalities just like we solve equations. So we're going to go ahead and move the smallest one here. So I'm going to add 8y on this side, add 8y over here. Those are going to cancel to be 0. And if I'm getting the y's over on this side, let's go ahead and move that 9 to the other side at the same time. So those are going to cancel. That's going to give us a negative 6 over here. Adding and subtracting, simplifying does not change the direction of the inequality, so we're going to leave it this way. So we've got a 4y on this side, and then we're going to divide both sides by 4. So here's what we get. Negative 3/2. Then we have a greater than or equal to y, and if we were to read this, here's how we'd read this. Y is less than or equal to negative 3/2. So here's what we're going to do. Negative 3/2, that's about negative 1.5, negative 1.5. So I'm going to put down that negative 2 is here and negative 1 is here. That would make 0 right here. That means what we're going to circle is this right here. So there's our negative 3/2. We're going to fill that in because it says it can actually equal that. And then the answers are actually less than that number. So we're going to shade to the left side. So it's going to look something like this. Now, the last thing we need to do is write it down in interval notation. Again, interval notation always goes from left to right. So always start down at the very end. Where do the answers start? They start way down here at negative infinity. So they go from negative infinity all the way up to negative 3/2. Always a round bracket, a round parenthesis around infinity. And then we determine whether this is round or square by figuring out whether or not it's included. This one happens to be included, so we're going to go ahead and do that bracket right there. Okay, on to number 9. We're going to get rid of this fraction right here by multiplying both sides by that negative 2. Remember, if you multiply by a negative, you have to switch the direction of the inequality. So this is going to be a 9 minus x. Switch the direction of that inequality, and then on this side we've got a 12. We're going to move the 9 to the other side by subtracting 9. And we're going to have a negative x over here, less than or equal to. This is going to be a 3. We've got that negative right there, so a couple different things we can do here. We can multiply both sides by negative 1. We can divide both sides by negative 1. That would just change the sign, or we can think, hey, we just want the opposite of each one of these things. So if we were to divide everything by negative 1, this is going to give us an x. This is going to give us a negative 3, and then we introduced a negative, so we do want the opposite of that. We want to switch that around so it looks like this. So there's the inequality. Now we want to graph this. So this is going to be, I'm going to put negative 3 about right here. We'll put 0 there. We're going to circle this. It is included, so we're going to fill it in. And then we're going to shade, let's see, the x's are greater than that. The answers are greater than negative 3, so we're going to shade this direction right here. So we'll make it look like that. So there's a graph of the answer. Now we want to write it in interval notation. Again, starting from the left, going to the right, where do we start getting answers? We start getting answers at negative 3, and they are included, so we'll use a square bracket there. And then they never stop, so they go to infinity. So that's our answer in interval notation. All right, take a look at the next one. We've got some simplifying to do on both sides, so let's go ahead and do that. So we'll distribute through. So we've got 8 plus 4x less than, we've got a 2x plus 6 minus a 15x. little more simplification here. I am going to blow this up just a little bit so we've got a little more room. So this is going to be 8 plus 4x less than, these two together are going to make a negative 13x plus 6. So we're going to move the 13x to this side. So we're going to add 13x over here. So that's going to cancel there, which means we ought to move the 8 to the other side. So we're going to subtract 8. So this is going to give us, holy cow, take a look at this. This is a 17x less than, this is a negative 2. Interesting. This is not going to work out evenly, but we can deal with that. So here's what we get. We get x is less than negative 2/17. So I'm going to go ahead and circle that. We're going to graph this. Now we do want to keep in mind what this is. This is a pretty small fraction. If you wanted to throw this into your calculator and get a decimal for it, it's going to be negative, so it's less than 0. But this would have to be 17, negative 17 on the top for this to be negative 1. So here's what we're going to do. I'm going to put negative 1 right here, and I'm going to put 0 right here. We're going to put a circle, and it happens to be an open circle about right there, just a little bit on the negative side. So this is negative 2/17 right here. We're going to leave that open, and then we shade. The answers are less than negative 2/17. So we're going to shade this direction here. So we'll go ahead and shade that in. And then in interval notation, we're going to write it this way. They go from negative infinity all the way up to negative 2/17, not including either one of those. So we're going to have round brackets around both of those. Okay, take a look at this last inequality that we need to solve here. We're going to multiply both sides by negative 4. Multiplying by a negative is going to change the direction of the inequality, so we're going to have 3t minus 7. So flip that around so that's a greater than. This is going to be a negative 20. Let's isolate that variable term by moving the 7, so we're going to add a 7 to both sides. This would be 3t. Adding doesn't change the direction of the inequality, so we've got a negative 13 there. And then we're just going to divide both sides by 3. So we get t is greater than negative 13 thirds. So we'll circle that. 13 thirds, that is, let's see, 3 goes in there 4 times, so that's about negative 4 1/3. So it's basically between negative 4 and negative 5. So I'm going to circle about right there. Now it's not filled in, and the answers are actually greater than that. The t's are greater than negative 13 thirds. So we're going to leave that open, and we're going to shade to the right, make it look like this. So the way we'd write that answer in interval notation, again going from left to right, the first time we encounter an answer is at negative 13 thirds, not including that 13 thirds, and then we go all the way to positive infinity. So we're going to go ahead and circle that. All right, let's come down here and take a look at this next portion. This says solve and graph each solution set. So you'll notice that this has 2 inequalities. It's got the word or, some of them have the word and. So these are compound inequalities, so we're going to need to be a little bit careful with these. So remember what those words mean. So and means both, and or means one or other or both. Okay? So that'll be important, and the only one that can be written without a symbol is an and. So this one right here technically is an and, but these are actually kind of nice to work with. They're kind of like 3-sided inequalities. So to solve this one, it's really pretty easy. All we have to do is subtract 2 from everything. So this is going to be negative 5 less than or equal to x less than 7. So there is the answer, and then we want to graph this. So this is going to be, let's see, negative 5 we're going to put down here, and 7 we're going to put up here. The 7 is open, the negative 5 is closed, and then when we would shade everything in between. So it's going to look something like that. Next one, the word is or. So when we were looking at this one right here, literally what this means is the x's, the answers are greater than or equal to negative 5 and at the same time less than 7. On this one, we've got to solve the 2 of them, and if either one of them is true, in other words, if either type of shading is there, that's going to be part of the answer. So when we solve this, we're just going to subtract 3, so we get x is less than or equal to negative 2. I'm going to write the word or here just to remind us there. We're also going to subtract 3 here. So this is going to be x is greater than negative, that's a negative 1 there, I think, okay? Now, you can't write these type of compound inequalities without using a word. You got to have the word or in here. Let's go ahead and take a look at what the solution might look like. So I've got -2 and the answers are less than that. So I'm going to put -2 about right here. We do get to fill that in, and the answers are less than that. So I'm going to shade this direction right here. And then on this one, it says x's, or the answers are greater than -1. So -1 is right here, so I'm going to circle that. They are not filled in, but we do need to shade to the right. Now, any type of shading is okay here, so this is the answer. So we should be in good shape there. It might be a good idea to write this in interval notation. So in interval notation, this would look like this. -infinity all the way up to 2. We'd include the 2, and then we'd start over again at -1, and then we go all the way to infinity. So if you were asked for something like that, that might be a good idea, a good way to write that down. We really like interval notation. All right, let's take a look at this. The word here is and, so they both have to be true. So when you've got the word and, we've got to be a little bit careful with this. So I'm going to go ahead and solve this. I'm going to subtract 1. So we get t is greater than -7. And at the same time, we've got to make sure that if we subtract 8, we get less than -6. So we're looking for numbers that are bigger than -7 and at the same time less than -6. So if I were to put this down here, so I'm going to put -7 here, and I'm going to circle that, and I'm going to, circle that, and I'm going to fill it in, and we would be shading this direction right here. So I'm just going to do a little bit of scratch work here. So we would be shading that way, and this one says if we're at -6, we circle that, we don't fill it in, and the answers would be less than that. So that would be this way. So this one would shade everything going this way, this one would shade everything going this way, but we need these to overlap because we've got to have both types of shading. So both types of shading would occur in between the two of these, so it would look like that. All right, so that would be the answer, similar to what we had up above. All right, let's take a look at this one. We're going to subtract 2. That's going to give me 3x less than 0, which is going to be x is less than 0. And again, I kind of like capitalizing and, just to remind me, I've got to make sure that both of these are true at the same time. On this one, we're going to subtract 3. So we get -x less than -2. Subtracting, remember, doesn't change the direction of the inequality, but if we multiply both sides by a negative, that would, and that would give us the positive x, and we would have a 2 right here. And again, we flip the direction of the inequality. So both of these things have to be true. So what we're looking for is x is less than 0. So I'm going to put 0 right here. And on this, and then we'd be less than, so that's going to go this direction right here. And this one is going to be 2. That's going to be about right here. And we're talking the answers that are more than that one. So this is kind of interesting. If you take a look at this, we need these to overlap. In order to have an answer with an and, they need to overlap. And these don't overlap. This one starts here and goes this way. This one starts here and goes that way. They don't overlap. So what do we write down for an answer on this one? They don't overlap, so there is no solution. No solution to this. We can't find a number that would make both of these true at the same time because they don't have an overlapping area. Okay, let's take a look at this one right here. This is an or, so any type of shading is going to be okay. If I subtract 5, that's going to give me x is less than -2. I'm going to write a big capital or here. We're going to subtract 5. So that's going to give me x is greater than or equal to -1. So let's graph this. I'm going to put some space here. So this is going to be -2. I'm going to circle that, and we're going to be less than that. So we're going to shade this direction. And this is -1. I'm going to go ahead and put that right here just for the heck of it. And we do fill that in. And we're talking about the ones that are greater than that, so we would shade this direction. And since this is an or, remember, or is one or the other or both, so anything that's shaded is okay. We don't need any overlap here. So I'm going to go ahead and fill this in like this, and there's our answer. So we've got the inequality part of the answer, like this, and then we've got the graph. We've got the inequality part of the answer. This is actually the solution here because there is no graph for that one. And again, I'm going to use an and here, and there's the graph right there. All right, let's flip the page over and take a look at this next part. And these are absolute value equations. Remember, when we're working with absolute value, there are nearly always two cases. They're always going to be two answers. A couple of exceptions, which we'll probably see here in just a second, but here's what we do. First thing we want to do is we want to isolate. This is already isolated, and I like drawing these two little lines to remind me. We're going to take the absolute value off, change the sign because this represents going to the left, and we're going to take the absolute value off, and we're going to leave that number alone because that represents going to the right of 0. So then we solve this. So we're going to add 3, so we get 2x equals -2. So we get x equals -1. There's one answer. And then the other one, we're going to add 3. So we get 2x equals 8, divide by 2. I probably ought to show that. So we end up with x equals 4. So these are the two answers, -1 and +4. All right, let's take a look at this one. Remember, the idea is we always want to isolate the absolute value. We've got that isolated, but in this particular case, it's set equal to a negative. And this is where it's really important that we remember when we find the absolute value of something, the very smallest it could be would be 0. Usually it's going to be positive. So what this equation is saying is that a positive equals a negative. And a positive is never going to equal a negative, so we don't even need to go any further. There's no solution on that one right there. Next one we want to isolate, so we're going to add 5. So we get the absolute value of 2y is equal to 18. Once we've got it isolated, we can break it into the two cases. It's either equal to -18 or it's equal to +18. We're going to divide both sides by 2, so we get a -9 on this one. Divide by 2 here, and we get a +9 on this one. So we get two answers on that one. And then let's keep going on this. Subtract 2. 5 absolute z equals 15. Divide by 5. Kind of thinking ahead there. So absolute z is equal to 3. It's totally isolated, so we're going to break it into the two cases, and these are the kind we love. There's really nothing to solve on the inside here because the only expression here is z. So those are the two answers. We get z equals -3 and z equals +3. And looking at these guys right here, so we're at the bottom of the page. Let's see if these are the last ones. Yep, these are the last ones. We've got 4 more to do, and then we're all finished. Okay, when we're dealing with absolute value inequalities, we solve them just like we do the equations up above, but we've got to remember what these inequalities mean. The word that connects the two pieces of this, the compound inequalities that are going to come from this, are and. So as long as the absolute value is on the left-hand side, if it's a less than, it's going to be an and. If it's a greater than, then it's going to be an or. And that includes the equal to and so forth. So this is already isolated, so we're going to break this into two cases. This is going to be a is, and we're going to compare that to -3. Remember, when we introduce a negative, we switch the direction of the inequality. Okay, and this is going to be an and. And then over on this side, remove the absolute value, and we just solve that. Now the cool thing is there's nothing really to solve here. So we're going to go ahead and we're going to write this down. So we've got a -3 here. We're going to circle it. We're going to fill it in. And we would shade the answers are greater than that. And then over here is a 3. We're going to circle that. We're going to fill it in. And the answers are less than that. Needs both type of shading. So this one's going to shade all the way over here. This one's going to shade all the way over here. They're going to overlap in between those. So this is going to be the answer right in between here. All the way from -3 to +3. So we can write it like this. We could also write it like this. We could say, hey, the answer is greater than or equal to -3 and less than or equal to 3. That would be totally okay. Or what would be awesome is if we knew how to do this, graph it, and write it in interval notation. In interval notation, it's going to be from -3 to 3, and because those endpoints are included, we need to have square brackets around there. Now, it doesn't ask for that. It just says solve and graph, so that's going to be in good shape. But if it does ask for interval notation, please make sure you do that. All right, let's take a look at the next one. It's not isolated, so let's go ahead and isolate it. We're going to subtract 5 from both sides. We're going to have the absolute value of x minus 4 greater than 5. The word that's going to connect the two of these is an or because it's a greater than. So this is x minus 4 is. We put a -5 here. We have to switch the direction. So it's going to be x minus 4 is less than -5. Or on the other side, x minus 4 is greater than 5. So we go ahead and solve this. We're going to add 4. So this is going to be x. X is less than -1. Or add 4. This is going to be x is greater than 9. So this is how we'd write the answer as an inequality. Let's go ahead and graph this. So I'm going to put -1 about right here. We'll just circle that. We don't need to fill it in, but the answers are less than that, so we'd go this way. And 9 is going to be over here somewhere. Again, we don't need to fill it in. but the answers would be greater than that, so that would be this direction. And the word is or. Remember, or means one or the other or both. So any type of shading is okay, so we're going to make it look like this. And there we go. So there's the inequality part of the answer. There is the graph of the answer. Again, with the word or, you have to write the word or. There's no way to get around that. And just for the heck of it, I'm going to write this down in interval notation. We start getting answers at negative infinity. We stop at -1, not including that. We use a union when we start up again at 9, and then we all go all the way to positive infinity. All right, we are getting there. Let's take a look at number 23. Again, when you've got an absolute value isolated and the other side is negative, it's worthwhile to stop and think about this for just a second. This is at the very least going to be positive, and this says a positive is greater than a negative. Well, there's really no number that we could put in here that would mess this up. So any number will work here. So any number will make this true. Any number will work. So what that means is the graph would look like this. It's going to be all real numbers. It's going to look like that. So we could say all reals. There's really not a way to write that down as an inequality or anything. So one of the best ways to write this down would just be to say, well, the answers go from negative infinity to infinity. Really, any one of those would work just fine. And then let's take a look at this one. So we're going to get rid of the 9 so we can isolate. So this is negative absolute x plus 4. Subtracting doesn't change the direction of the inequality, so we're in good shape there. We do need to isolate this a little bit further, so we're going to divide both sides by -1. So what this is going to do is, I'm going to write it over here. This is going to give us the absolute value of x plus 4, and then we divide it by a negative, so we have to switch the direction of the inequality, and that's going to be a 4. Now it's isolated. We did switch the direction of the inequality, so here are the two cases. We've got a -4 here, but we need to switch that so that it looks like this. Remember, we introduced a negative, so we switched the direction of the inequality. It's a greater than, so the word here is or, and then on this side we've got x plus 4 is greater than 4. So let's go ahead and solve. Subtract 4, we get x is less than or equal to -8, or on this one, when we subtract 4, we get x is greater than or equal to 0. So here's what the inequality looks like. Let's go ahead and graph this. I'll put -8 here. We'll circle it. We do need to fill it in because it can be equal to that. And the answers are less than or equal to -8. So we're going to shade this direction. And then I'll put 0 over here. We do need to fill it in. The answers are greater than or equal to 0. So greater than would be this direction. So we're going to go ahead and fill it in. Now, you'll notice that I went ahead and filled it in because remember, when it's an or, any type of shading is okay. With an and, you've got to be a little bit careful to make sure that you only shade the overlap in the final answer. This is the final answer, but again, I'm going to write it in interval notation just to make sure we're clear here. Negative infinity all the way to -8. And then union again, starting at 0, going all the way to infinity. Now, for those of you that are paying close attention, you'll notice that I made a mistake here. The mistake isn't a big one, but you will get docked points for it. Right here, that round bracket says that that -8 is not included. We don't want to make a mistake like that. We want to make sure that that's a square bracket. Remember, always round around infinity, but when you have a number here, you've got to make sure if it's included, it's a square bracket, just like we did here. If it's not included like we had here, then that's a round bracket, an open bracket. All right, good luck on the test.